Hello, another short video. In this video I'm going to be continuing the work I did in the replay tool, which was to check that the data quality was good and crop the file to an area where I wanted to analyze. So I'm going to run up multi-tool, and it's gone into analysis mode because I've previously been using that. So we've got an FFT display on the top, got a Campbell on the bottom, results area, I'll cover this in a minute, and blade response. So I'll load a test, and because I've just loaded this once, it's here, and this is the crop data we created in the replay tool. You can see 4,000 revs. So we'll load that, it's done its checks. And there we have a response. So if you hold the mouse over the display, it tells you which rev number it is, gives you the speed, and gives you the amplitude of whatever's underneath. Now, because this is a simulated file, the background noise is very low. It's still there, but it's very, very, very low indeed. So 8 probes, 1, 2, 3, 4, 5, 6, 7, 8. If you click on one of these probes, you'll get it display on the main probe. So go back to on the main display, I go to probe 1, and obviously analysis uses all the data from all the probes to do the analysis. So if you adjust the amplitude with the mouse wheel, I'm going to zoom in, and as I did on the replay, if I left mouse click there, left mouse click there, it will track through the response, and it will tell me, as it did before, ND -4, 366 Hertz, 100% confident it would be. It's a simulator file. What that's done is that's translated that down onto the Campbell, and if you're not happy with that and you think it should be somewhere else for whatever reason, you can move it. You click on the analysis result button, it's highlighted it, you can move it up and down, stretch, etc. Okay, but I know that's correct and I'm happy with it. So what I need to do is have a mode line. We haven't used or analysed this test before, so what I'm going to do is I'm going to create a mode line. Mode line editor's up, hold the control key down, I'm going to click to the left of it, I'm going to click to the right of it, let go of the control key, click again. That's now created the mode line, and that can be moved around and edited just like everything else, but I'm fairly happy with where that is. So I'm going to close the mode line. If you can see in the mode line editor, it's the first one, it's called it mode 1. Okay, I shut that. If I go to show the mode numbers, there you go, mode 1. Right, so we've now got a mode line, we've got a response. You don't need to do this step every single time. This is all about helping you build the Campbell correctly to do the analysis. We now need to create an analysis area. Analysis areas are contained inside mode lines, and they tell the system to do a full analysis throughout the whole mode line. So create an area, again left control, click, and we have, there you go. So, and it's adjustable. You can't pull it outside the mode line. The mode line acts as its bounding container. So if I pull that to there and pull that to there, you can see on the display above it's highlighting where we are. So if I moved it off, it'd be unwise to do that because most of the response is now outside of the area I'm going to analyse, and same on the other end. So we've set that up nicely. I'll make that a bit bigger. There we go. I'm happy with that. So I'm going to close that for now. No, in fact, if I try and do an analysis from there, it'll complain because the template's not been saved. So there you go. A new template must be saved before performing analysis. So I'm going to click on the Save Template button, and that's opened up inside the crop data folder. Keeps the templates with the data, and I'm going to call that analysis 1. You can call it whatever you want. And if we go to the folder structure, log data cropped, you'll see, there you go, analysis 1. Now we've got that, we could perform an analysis. But I'm not going to do that just yet. I'm going to reset everything and show you what we've just done. So I'm going to change modes. It's the easiest way to just flush everything and go back into analysis. And it saved the template. I forgot to clear the template. Never mind. I'm going to reload the crop data. Okay, so we've loaded the data back in. I'm going to clear the window. So this just demonstrates, if you see this little symbol here has now appeared, if you hold the mouse over it, it tells you that it's found an analysis template. So we can either click on that and go and found our template, and there we go. Again, as I explained before, the viewer is very clever. It knows that it's looking for a template. It will only show you template files. So if you go to demo, logged, nothing else comes up except valid templates. You can have as many as you want. We've just created this one, so I can click OK. And lo and behold, we're back where we started. Okay, and I could go and create an analysis if I wanted to, and then do analysis. But something else I want to show you. If I reload it again, you'll see the little mouse, a little hint of orange around it. What that means is if you right click on that, it knows analysis 1 template belongs to this data set, and it says save you all the trouble of loading it, just right click and you can load it directly from there. It's just a bit of a quicker way of getting your relevant templates. Now there's another little trick. I'm going to bring this back up. I'm going to copy that and I'm going to go up a few directory levels. You can put it anywhere underneath the test, it doesn't matter. So in here I'm going to create a new folder and I'm going to call that common templates. And in there I'm going to paste. I'm going to call that analysis common. Okay, so what I've done there is I've created a folder, a copy of the template in. You can change its name, doesn't matter. For this all intents and purposes, it's the exact same analysis, but I'm just demonstrating a point. If I then load again the crop data, you'll see the hint to say there's something there. If I right click on it, it's now picked up the common analysis and the local analysis. Now anything that's common is green, anything that's local to the data is black. What this allows you to do is, if you come up with a template, if you're doing 4 or 5 maneuvers or 10 or 20 maneuvers and they're all very, very similar indeed, rather than copying and moving around 20 different templates, and if you edit one then that gets orphaned effectively, you can just use a common template at the top of the tree. You can put that in log data and you can put it in the test for the day if you want, but it works its way back up from the data, and the first time it finds that folder it uses what's in it. But for the sake of this test I've put it in the root of the project folder. Okay, so I'm going to load the common analysis which we've got, and I'm going to go and do an analysis. So analysis areas, it's area 1 for mode 1, as I've said. Start, stop, it's fitting, it's using a modal fit, not an engine order fit, and it's a single, not a double. We'll do all the blades because it's a relatively small file, it won't take long. Click go, and it's now analysing throughout the area. The area is contained inside the mode line, and the mode line was done around analysis result. And it's finished. Okay, get rid of that. Right, the results, there's a little orange hint appearing around that. We can now see we've got a file. we've got some options for this. If you've got loads in here, you can limit it to the current template and today. All maneuvers, accelerations or decelerations. If the filters are active, you've got an orange bound here. If they're not, then it isn't. So if I hold the mouse over it and just wait, it'll give me all the details, the configuration used, the analysis file, mode, type and fit. Okay, and this little symbol means it was an accel. You can't always get clear accel decels depending on what the actual maneuver is, but if I want to look at that, I'll double click on it and let's open it up. There's the response. Peak value is the red cross at the top. Blade response, fit response. I'm going to change a few of these. I'm going to get rid of the legend. I'm going to show uncertainty. And I'm going to plot it against speed. Now I can save that if I'm interested in the data or want to export it for a report or play with it in Excel. I can save that and it will export it out. So what we've basically got here is the response. It's a simulator, so lo and behold, it's a lovely response. And at the peak value of 6, if I hold the Shift key and move the mouse, it gives you uses the X position of the mouse to give you the data at that point. So 6.43, 364 Hertz. Okay, no uncertainty, no surprise there. 4.9 engine order, so it's almost synchronous at that point, and 4,500 RPM. So totally confident, 100%, very little uncertainty, lovely result. Okay, as I said before, you can save that if you want. I'm not going to go into the details about some of the next step of processing. That's more analysis plus or analysis number 2. But you can see, what I will show you is, that's blade 1. Okay. If you hold the Shift key, I don't know whether you saw it briefly, I'll do it again. There you go, hold the Shift key for cursor data comes up every time you open that. So that's cursor data on the current blade, which is blade 1. If you do the same thing over here, blade 2, 3 gives you the peak value, and lo and behold, as I said before, it's a simulator, so all the blades have come out with the same amplitude. If you hold the Shift and double click again, you can change the current blade. So I'm holding the left Shift, blade 10, it says up here, blade 10, and they're all going to look the same. It's just the way the simulation was done. Okay, we covered quite a lot of ground, so I'm going to leave that as it is. Thank you very much.